So in this segment, we try to look at the solution to the 2025 Science Paper 2, question number C2, that is in section C. It says silver chloride is an insoluble salt which can be prepared by reacting aqueous sodium chloride with silver nitrate. Then A, describe how a dry and fairly pure sample of silver chloride can be prepared in the laboratory. So how can we do that? They have given us the starting reagents, which is actually a good sign. So therefore, what we can do is that obviously, hopefully you're able to see. So what we can do is that since they have given us the reaction, what you can do, the first step that you can do, step number 1, is mix aqueous. So you can mix aqueous sodium chloride and silver nitrate. So that's the first thing. So mix the two reagents, sodium chloride and silver nitrate. So when you mix them, you're actually going to obtain a precipitate. So that is what you're going to, so mix sodium chloride and silver nitrate to obtain a precipitate of silver chloride, right? Then the second step that you can do is filter the resulting mixture to obtain the precipitate on the filter paper. In this case, that would be silver chloride. Then we can say that wash the residue. So wash the residue, which is actually silver chloride, with distilled water. Okay, so you want to remove any impurities of the sodium nitrate that is going to be formed. Then we can simply say dry the silver chloride between filter papers in the sun, or you can use an oven, or you can simply use a desiccator, something that can actually help to dry out. So this is what they wanted you to do, and hence you earn yourself the 4 marks. Then B, there says that write the net ionic equation for the reaction in A, including state symbols. So they want you to write the net ionic equation. Now, you don't need to struggle too much in this case. When you look at the salt that they want to obtain, it is actually silver chloride. So what you need to ask yourself, what are the two ions that are found in silver chloride? The silver and chlorine. So remember, you just say silver carries a positive charge because it has a valence of 1. This is in aqueous, reacting with chlorine ions. So chlorine ions, that is also in aqueous, and that will produce what we call, when the two ions react, it is going to produce silver chloride, which is a precipitate, and that is the ionic equation. So it's the simplest way that you could have actually gone about. So for an insoluble salt, just identify the two ions that are making up the salt and write the two separate ions, but give them the charge they carry. When these react, they form up that. If at all it needs to balance, you can actually balance out that. So that's the way it is. Let's move on to C. It says use your equation in B to calculate the mass of silver chloride expected if 1.7 grams of silver nitrate reacted with excess sodium chloride. So in this reaction, it was it was actually sodium chloride, which was in aqueous, reacting with the silver. It was reacting with silver nitrate, which is also in aqueous. And when the two react, remember sodium is positive. Let me just give you, this is positive, chlorine carries a negative. this is again positive and that carries. So the one which is positive combines with the one which is negative, and that produces sodium nitrate as one of the products that you're going to have. Then the silver, which is positive, combines with the negative, and that gives you silver chloride, which is a precipitate. So give it a solid state there. So you can see it's not complicated how to obtain the result there. So is this equation balanced? Well, it actually is self-balanced. Now, according to the equation there, equations C, the C part there, it says that in your use your answer in B to calculate the mass of silver chloride expected. So the answer in B, in this case, obviously the wanted, I know I went directly, you could have gone like that, and you could have actually, splitted up the ions and cancel out the spectator ions so that you come up with that. And that's why they said use the answer to part B. I'll show you at the end of it how you can actually do it. There's no problem with that. So it says use your answer in B to calculate the mass of silver chloride expected if 1.7 of silver nitrate reacted with excess. So this was excess. So it was excess, meaning this is the limiting reagent. So what you just needed to do, let me see if I have a periodic table handy with me nearby so that we can actually just get to use it. All right, so we need just to find the mist of this. So what is the mist of silver nitrate? So I want to show you. So the mist of silver nitrate, so there's 3 oxygens multiply in this case by 16, which will give me 48. Then sodium there is actually 1 multiplied by the mist of sodium, which is 14, so it will give me 14. Then silver again is only 1 multiplied by the mist of silver. If you go to the periodic table, I'm just trying to look at this element, it is simply 108, so that will still give me 108. So what is the total mass that we are going to have? Sorry, I didn't carry a calculator with myself. Now, of course, we actually need a calculator so that we are able to answer that question, right? Okay, so we can still just try to calculate it ourselves, even without a calculator. Sorry, I don't have a calculator nearby. Okay, I think I've found it. So what we do is very simple. So we can say 48 plus 14 plus 108. So this is going to give me a mist in this case of 170. That is for silver nitrate. Then we also need to find the mist of silver chloride. So if you look at it, there's only 1 silver there. So 1 times 108, which will still give me 108. Then chlorine is 1 times 35.5. It will still give me 35.5. So what will be the mist when we add that? So it will be 108 plus 35.5, and that is going to give me 143.5. So now you are just going to compare in this case. So you are going to compare and say, oh, from the balanced chemical equation, 170 grams of silver nitrate produced what mass of silver? So it produced 143.5 grams of silver chloride. Now here in the question, they told you to say what mass of silver chloride is expected if 1.7 of silver nitrate reacted. So you're going to say, what about if 1.7 grams of silver nitrate reacted? Then what mass was that? You don't know, so that will be x. Then you can cross multiply. So this times that will give me 170x is equal to 1.7 multiplied by 143.5. To find x, I will divide 170. What I do this side, I also do it the other side. You can see x will give me what? What is that going to give me? So we can work out that to be 1.7 multiplied by 143.5. So that's the answer we get. We divide it by 170. So if I divide it by 170 to 2 decimal places of 1.44, and this is going to be grams of silver chloride. So this is actually what is expected when they use 1.7. I hope it's making sense for you and you're able to pick it out. Then D, says that calculate the percentage yield if 0.95 grams of silver chloride was obtained. Now this value that we have calculated here is what we also call as being, this is what we call as being the theoretical yield. What you get from a balanced chemical equation is called the theoretical yield. Please, if you don't understand on theoretical yield, just go to my playlist for chemistry. You'll find more concept questions that I've actually covered, then you can actually get to learn. So they want us to find the percentage yield. So the percentage yield is equal to what we call as being the actual yield over the theoretical yield, then you multiply this by 100. So if you notice, they gave you 0.95. That is actually the actual yield when they carried it experimentally. So it will be 0.95 over the theoretical yield 1.44, then multiply this by 100%. So what is that going to give us when we work out that 0.95, over 1.44, then multiply by 100? So it is giving me, in this case, 65 to 1 decimal place. Okay, so when we round it off, that would be 10. So that would be approximately, 66.0%. So 66.0% is actually the percentage yield. Thank you so much for watching. If you love what we do, please subscribe to our channel. We appreciate you watching so that you can actually learn. Please look out for some other video series in physics, chemistry, biology, additional mathematics. If you are doing pure science, watch out also for your series as well.